All right, we are going to start section 4.5, talking about the graph of sine and cosine and tangent. So let's start with y equals the sine of x. Now these graphs are different than most other graphs we've dealt with. So let's fill in a table first. The sine of 0 is 0. Use your unit circle to find these, right? The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is negative 1. The sine of 2 pi is 0. And it keeps repeating over and over and over and over and over again. So I have points at 0, 0. Notice this graph is a little different. This second notch here is labeled pi over 2. It's really hard to see. The fourth notch is pi. All right? So pi over 2, 1. Also be careful, my graph goes up by halves. Pi, 0. 3 pi over 2, negative 1. 2 pi, 0. And with what we know about trig functions, they repeat over and over and over and over, which means I go positive 1, 0, negative 1, 0, positive 1, 0. And same thing on the other side, it just follows the pattern. And then also notice that this is a sine curve. If we graph more points, pi over 4 is square root 2 over 2, which will show us that it's a curve. We curve smoothly up and down through our peaks. Arrows on the end. Down, up. And mine's a little shaky, but there is my graph of y equals the sine of x. So let's analyze this a little bit. Starts at, we consider the starting of sine to be 0, 0. Ends at, we say one cycle ends at 2 pi 0. And the middle, right in the middle is pi, it's at also 0. It repeats every 2 pi. The maximum value is y equals 1. The minimum value is y equals negative 1. It never goes above or below those. X-intercepts. We cross the x-intercept at x equals 0, at x equals pi, 2 pi, 3 pi, 4 pi, 5 pi, on and on and on. We say just n pi. The y-intercept is the point 0, 0, just one of those. Now let's look at the cosine graph. Again, we'll fill in this table. So the cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is negative 1. 3 pi over 2 is 0. 2 pi is 1. So we graph those points. 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, 2 pi, 1. And just like with sine, this one repeats. So now I go back to 0, then negative 1, 0, 1, 0, negative 1. And same thing on the left. Follow that pattern to make my back and forth. And again, this is a curve. So there's our graph of y equals the cosine of x. To analyze this one, we start here at 0, 1. We end one cycle at 2 pi, 1. And the middle is pi, negative 1. So with sine, we start, end, and have a middle at 0. Cosine, we start and end at 1. Our middle is at negative 1. This repeats also every 2 pi. The maximum values are y equals 1. The minimums are y equals negative 1. Never go above or below. X-intercepts, now they're a little different. X-intercepts are pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, every odd pi over 2. Make sure n is odd. There we go. N pi over 2 if n is odd. The y-intercept here is 0, 1. So that 0, 1 is a big telltale factor whether you're working with a sine or a cosine. Now we'll look at tangent, because tangent is the funny one. All right, so starting off for tangent, the tangent of 0 is 0. Tangent of pi over 4 is 1. The tangent of pi over 2 is undefined. 3 pi over 4 gives me negative 1. Tangent of pi is 0. 5 pi over 4 is 1. 3 pi over 2, it's undefined again. 7 pi over 4 is negative 1. 2 pi is 0. Anywhere our graph is undefined, that's actually an asymptote. So at pi over 2 and 3 pi over 2, we actually have asymptotes. And you can kind of tell by how far apart they are. Every 4 lines on this graph is going to be another asymptote. On the left and right side of the y-axis. Remember that asymptotes are important because you cannot cross them. Vertical asymptotes cannot be crossed. Not on above, below, whatever, cannot cross them. So my points are 0, 0, pi over 4, 1. And then 3 pi over 4, negative 1, 0, 1, negative 1, 0. It's hard to kind of tell this one, but you can tell it in this middle section here. It starts by the asymptote, does a squiggly, and then goes up by the asymptote forever. Make sure you don't cross the asymptotes. Make sure you put arrows on either end, which means for this first piece of it, we have to put an extra dot and make our squiggle. Make sure you squiggle through to get all those points that are important. Which means in between each set of asymptotes, we go negative 1, 0, 1, and make a squiggle through it. Make sure you draw as many cycles of this as will fit on the paper. I ran out there. And negative 1, 0, 1. And there's the graph of our tangent function. It's got a lot of pieces and it repeats more often. So, important pieces of tangent. We started tangent at 0, 0. We started our graph there. It repeats every pi now. There is no maximum or minimum because it goes up and down forever. X-intercepts, it crosses the x-axis at x equals 0, x equals pi, 2 pi, 3 pi, 4 pi, on and on and on, every n pi. The y-intercept is 0, 0. Notice that it has the same x-intercepts as sine. And a few more important things. Vertical asymptotes are at x equals odd multiplicities of pi over 2. These are the zeros of the cosine function. It has zeros where sine of theta is 0, and the period is pi. Period is how often it repeats. And the first period splits the y-axis, part on either side. And there are our basic trig graphs.